Let's move on to the third team. So I'm calling on stage Micape, Motorway Micro Aerodynamic Power Engine. That seems cool. Micape. Okay.
Hello to everyone. My name is Yannis Giannakou, and I'm a mechanical engineer. I represent my Micape team. Micape is the acronym of the idea and means micro aerodynamic power engine. The idea refers to a renewable energy technology based on an innovation concept for electricity production using small axial wind turbines suitable for installation in a long-distance traffic networks. Let's see the operating conditions of the proposed product. The first parameter is the wind casting or backwind created when the vehicles pass the aerodynamic shells on a motorway. So the cars create streamlines, and the velocity vectors goes direct to the rotor of the engine and create electricity. The second parameter is the solar radiation by using an integrated PV panel fitted to the top of the shell. So we are talking about a hybrid technology, I mean combination of photovoltaic technology and wind turbine technology. And of course, the third parameter is the nominal wind speed, depending on weather conditions. For example, when we have a potential up to 5 meters per second, I believe that we can create enough energy. Let's see now how Micape works. Micape is intended to produce electric power, contribute this energy to the grids. So we can use this energy for create self-sustainable motorways, advertisement billboards near the motorways, and of course, we can cover electricity requirements for municipalities and households that need electricity. For example, 20 engines can cover an average residential project on Cyprus. We are a strong team of mechanical engineers having experience on renewable energy technology and aerodynamic designs. We have already done the simulation of the prototype engine using the steady stable model and calculate the output of the product. And we believe that we have a good technology, fully renewable technology that will be competitive to the market. Thanks for your attention.
Thank you. It's pretty interesting energy harvesting solution. So I may go that way, but I will give to Lawrence because I think it touches a bit your market. So I just, next is, yeah, but Lawrence, just start because it touches a lot your market, so I would like to hear from you first.
Okay, so good presentation. I like you, I like the product. I used to develop pretty much things like that for an energy company, so I'm quite familiar with this space. In terms of energy output per year, what yield are you expecting? How much energy could one of these produce?
Okay, the estimations gives me the pressure from the pressure differential between the two sections of the shell, which is aerodynamic shell. I have indicated number for pressure 800 Pascal. This number gives me I can believe that we can create electricity for 300 RPM to the rotor.
So all I need to know is how many kilowatt hour per year are you expecting?
Rated power at maximum 900 watt each engine.
But kilowatt hours per year? Any ideas?
I calculate this number, but I just remember the number of the range with the consumption of the house. One residential house, 20 engines can cover annually this
Annually?
consumption.
Annually? They cover annually.
We can cover one residential project with 20 engines on a motorway. So we are talking about a micro engines.
Sure. I mean, for me, the area is exciting because there's more copper in the streets of New York than there is left in the world's reserves. So if you can power things off-grid, that's exciting. But it's a purely an economical decision on your market. You know, if it generates 100 euros a year worth of energy and it pays back in 5 years and you can retail it for 500 euros with enough margin, it's a great product. We just need to know that. That's really, I think, the crux of what this comes down to.
I believe the most important things on this is the cost of the final product. This is the price of the product under contract with the manufacturer, under term conditions. We are not talking about the prototype development, but the final product, I believe that it can be in a low cost. So we can be competitive.
Okay, thank you.
Okay. I would definitely agree. You have to calculate the ROI, the initial cost, how many kilowatt hours per year in order to just generate some financials. Okay.
So it was the same question for me, but I don't want to ask again because he didn't calculate any balance with the gross cost and the revenue. Lots of the energy projects always has the problem in the same point. So I just want to pass because he can't answer the question.
Okay.
He doesn't know the market size also. How are you going to be big? What is your market size?
Okay, I don't have options because I am not the owner of the grids, of the electricity grids, and also I don't have access to the motorways. So I have a plan to certify the product, optimize the product, and if I can patenting and get revenues from the percentage to the sales. That's the only way for the moment. Okay.
All right. Thanks for the presentation. It's quite a different product, so it's nice to see some innovation. 2 quick questions. Firstly, will you only be manufacturing? Is the business model to manufacture these and then resell, or are you going to be also involved in any of the installation operations at all?
Mm-hmm. So my company is only a consulting. I offer only consulting services. I'm not a manufacturer, but the product could be sold to the manufacturers.
Okay, so you'll get a licensing fee. And you mentioned you have a team of mechanical engineers. Can you tell us a bit more about who's actually on the team, how big it is, and?
Okay, my team is another partner, mechanical engineer, graduate from the same university of me, Leonidas Varnava, and also Christos Dimitriou, who is an engineer. And of course, I work as external partner with my university, University of Western Macedonia in Greece, and Cyprus University of Technology.
What was the inspiration for the product? What gave you the idea to do this?
It's my, the idea it's mine. I think it, when I was in a laboratory in the university.
Thank you.
Okay, just Nick and then feedback.
Do you have any patents? Have you applied for patents, or are you planning to apply anytime soon?
I didn't do something like this, but something that I will do.
Okay, and last question, is it just an exercise in simulation? Do you maybe have a prototype, a smaller scale?
Okay, we have done simulation in real conditions using the CFD model, the ANSI software, but we calculate only the steady stable model. So just calculate pressure differential between the 2 sections. So we have indicate value for the speed of the rotor. This is my opinion.
So I mean, Nick, if you would like to go on with some consulting and some feedback, but just as far as I understood, there is an initial idea stage right now. They have some computational methods, fluid mechanics, so they have some results on the computer, and actually they're just right now trying actually to build some prototype, something like that. So, Nick.
Great. So, pitch-wise, I think it was a really nice pitch. You explained a really complicated concept in really easy-to-go slides, and I think everybody understood that. I think, and as the previous speakers said, you need to make some calculations, some economic calculations. So there is a thing called LCOE, levelized cost of electricity, and it's actually for the project the cost that you will have per megawatt hour capital expenditure, so to build it and to operate it. And this is the measure that every energy project is measured upon. So I think you need to calculate that in the future. And if then you see that in this calculation you are competitive, I believe it might make sense to make a small prototype, so to have actually the proof of concept in a smaller scale, and then I believe it will be easier to find financing and to scale this project up.
Thank you.
Tom, your turn. Tom, go that way. Not okay, Lawrence. Yeah.
So my feedback is, as I said before, I like you, I like the presentation. It summarizes what it does really well. I just did a bit of research, and it costs 270 euros per year to power a house in Italy. That's the best I could get. So it's 1,350 euros for 5 years of energy. So if you can give me a thing that comes back saying that it will cost out over 1,350 euros and you can make that work, then it's like a no-brainer. And I really like that. I'd like to work with you. I'd like to find out more if you can add more value around those numbers.
Tom.
I don't really have much to add to this. Presenting it for what it is, you might want to start by indicating you don't have an intention to be a manufacturer. I was waiting for the pitch to hear, cost to produce, unit per cost of goods sold, and it wasn't until the end during the Q&A that I really understood you're looking to license it. That's just a style piece of advice. You might want to lead with that.
Thank you.
My comments are thanks. I think I would echo everyone's comments that the presentation was nice and easy and clearly presented. My suggestion would be to explore whether you should have more diversity on your team. It sounds like you're very engineering centric. To look at the business model and financials, you might want to have someone with more business background and diversify your team a little bit.
And also, if you put some benchmark into the project, it's going to be very helpful, the presentation, If you put the benchmark to the, alternatives, what's going on, what do you produce, the energy consumption, the numbers. I want to see some numbers.
Okay, 300 kilowatt hours per square meter a year is the average consumption for an energy class A house in Cyprus. So 20 engines can cover this consumption.
Mm-hmm. So I think very positive feedback. Energy harvesting is a very hot domain in the CleanTech. You should work a lot on the numbers. You should calculate and make the impact to the houses, make the impact, the projections through the years. I would definitely suggest to go on and research for patent. Okay, if something exists out there, or if it does exist, then how we could differentiate and then file a patent. I think it's very nice and interesting technology. And if you do that, I think you can follow up and go on to the next stage. Thank you.
Thank you very much. Thank you.
Good job. Okay.